Okay, you guys, we're actually going to take 2 days to learn 3-3. So we're going to start today with learning some proofs about parallel lines. And then on Monday, when I return, we're going to learn more proofs with parallel lines. And we're also going to learn how to do a construction where we're going to come up with a parallel line that passes through one point that's obviously parallel to another line. So that's what we're going to be doing on Monday when I come back. So I hope you guys had a great week so far. And yeah, so let's get to it. Okay, so anyways, we've got 3-3 proofs with parallel lines. We already learned these theorems that said if you have parallel lines, right, if you have two parallel lines that are cut by a transversal, then corresponding angles are congruent. We also had, again, alternate interior angles. They're assuming that you're starting with parallel lines, and if you have parallel lines, then alternate interior angles are congruent. The alternate exterior angles theorem, again, starts with always, you have to have two parallel lines in order for the alternate exterior angles to be congruent. And then, of course, consecutive angles also have to have parallel lines. And then if you have parallel lines, then the consecutive angles add to 180, right? That's what supplementary means. Now, we have the converse of these. Remember converse? Remember how we talked about the shoes? It just takes your if and your then, your hypothesis and your conclusion, and it switches it. So instead of all of these starting with parallel lines, parallel lines, parallel lines, parallel lines, right? It's always following if. Now we're going to take it and we're going to switch it. So now instead of it starting with parallel, it's actually going to be following in the conclusion as parallel. Okay, so if you look at our converses here, now it's saying then the lines are parallel. Then the lines are parallel, right? Over and over again. Okay, so for the corresponding angle converse, you have to have two lines cut by a transversal so that the corresponding angles are congruent. So now we're assuming that the corresponding angles are congruent, then the lines are parallel. If the alternate interior angles are congruent, then the lines are parallel. If the alternate exterior angles are congruent, then the lines are parallel. If the consecutive angles are supplementary, remember, if they add to 180, then the lines are parallel. So we're just taking the hypothesis and the conclusion and we're switching it. Okay, if you remember me holding my arms out to the side and then actually switching them like we're tying our shoes, that's that whole converse idea. Okay, so we're going to be using the converse anytime we are being asked to prove parallel lines. Remember the symbol for parallel? Line A is parallel to line B, or line C is parallel to line D. So whenever we're trying to prove that lines are parallel, we're going to be using the converse of these, okay? All right, so in this problem, it says, is there enough information to conclude that M is parallel to N? In order for M to be parallel to N, we need to be able to show one of these pairs of angles are congruent. So either corresponding angles, alternate interior angles, or alternate exterior angles are congruent, or we have to be able to prove that consecutive angles, remember the ones that are both inside and on the same side, see the C? If those add to 180, then we can prove they're parallel. So we can't assume that we have any of those angles that are congruent. The only thing we can assume is vertical angles. Okay, so I can't just go, oh, this one's 75 because corresponding angles. You can't do that because we don't know right now if M and N are actually parallel to each other. They look like they're drawn, but what if they were drawn like this? Then M and N would not be parallel. Okay, so we can't just assume that these two angles right here are going to be the same because that's what we did before. Okay, we can only assume what we had previously. Okay, so anyways, if I know that this is 75, I know no matter what, even if M and N weren't parallel, that vertical angles occur right here. Okay, that doesn't, the fact that M and N are parallel has no effect on those two angles being the same. Okay, so that's the vertical angle theorem. And then we also have that this one is 105 degrees. So, of course, the other one is 105. Again, using the vertical angle theorem. So now that I have that, I can look. Do you see the C? Do you see these consecutive angles? Our converse over here said if two lines are cut by a transversal so that the consecutive angles are supplementary, then the lines are parallel. Are these two, 75 and 105, are they supplementary? Do they add to 180? They sure do. Okay, so we can say yes, M is parallel to N using the consecutive angle converse. Okay, and again, when you're trying to prove that they're parallel, you're always using the converse. Okay? All right, so first proof. We are given that angle 4 is congruent to angle 5. And we are trying to prove that G and H are parallel lines. Now it says prove the AIA converse. So that means I can't use alternate interior angles to prove that the lines are parallel. So that one's off limits. But all the other ones I can use. So I can use everything except for these alternate interior angles. Okay, so I could use this converse, I could use this converse, or I could use this converse. Okay, and that's again because it says prove the AIA converse. Okay, so let's go ahead and begin our proof, right? We start every proof by writing down our given. So in this case, angle 4 is congruent to angle 5, given. Okay, so like I said, we can't use alternate interior angles. So I can't look at this and go, oh, 4 is congruent to 5. I can't use that, okay, because it says prove the alternate interior angle converse. So do you see any other types of angles here in this picture? Specifically, vertical angles. Right, don't you guys see we've got 1 and 4 here that are vertical angles? So I can write down here that angle 1 is congruent to angle 4 using the vertical angle theorem. Okay, so just like last chapter, we use the transitive property. Okay, so if we look at this, do you see anything that repeats itself? 4, right? So I can go ahead and use a transitive property to state that angle 1 is congruent to angle 5. Now, if I look at my picture, 1 and 5 happen to be what type of angles? Are they consecutive? Do they make a C? No. Are they alternate interior? No, 4 and 5 are alternate interior. Are they alternate exterior? No. Nope, they're in the same location, right? They're both on the left side of this transversal. They're both above line G and H. So we call these corresponding angles. So if we look back up at our theorems, we know that angle 1 and angle 5 are corresponding angles and they're congruent. So if I reread this, it says if two lines are cut by a transversal so that the corresponding angles are congruent, which if I look aren't, 1 and 5 corresponding angles that are congruent, they sure are. So our conclusion now is that then the lines are parallel. So now we know that our two lines G and H are parallel. So in our last step here, we can state that that line G is parallel to line H, and that was using corresponding angle converse. And again, it's converse because we're trying to prove that these two lines are parallel. Okay, will always be the converse every single time your reason here is parallel. Okay, so we're going to go ahead and give another one of these a try. So just like last time, let's set up our proof. We're given that angle 5 is congruent to angle 8. And again, our goal is to prove that we have parallel lines. Specifically, they're A and B that we're trying to prove are parallel. And again, we aren't allowed to use certain things. Specifically in this one, it says we cannot use the alternate exterior angle converse. Okay, so that means nowhere over here can we use AEA. Okay, so when I look at my picture, I've got some vertical angles, right? 5 and 6 are vertical angles, so I could write down that. So angle 5 is congruent to angle 6 using the vertical angle theorem. See any other vertical angles? I hope so. Right? 7 and 8 are also vertical angles, so I can write down those as well. Now, just like our proofs in the last chapter, do you see anything here that repeats? So let's get rid of them. Right? 5 repeats, 8 repeats. So now I'm left with angle 6 being congruent to angle 7 using the transitive property. Okay? So now that I have that, I look at my picture. I look at angle 6. I look at angle 7. Do those types of angles have a special name? If it helps, just redraw it with just those angles. Hopefully you guys see they're on the inside of these parallel lines, and they're on alternating sides of this transversal, right? One is on the left, one is on the right. So what type of angles are those? Alternate interior angles. So we know that the alternate interior angles here are congruent. So if I go back up and I look at all of my converses, I know I crossed this one out, but you guys can still read it right here. It says, if two lines are cut by a transversal so that the alternate interior angles are congruent, which isn't that what we have here? We have a pair of alternate interior angles that are congruent. So if we have that, then the lines are parallel. So now we can prove that A is parallel to B. And again, that was the alternate interior angle converse. We always use the converse every single time we have parallel lines. Now, I'm not expecting you to circle this converse and put the arrow to the parallel lines like I just did, but you'll notice I'm going to do that every single time I do a proof for you that deals with the parallel lines, only because I want you to remember that every single time we're trying to prove two lines are parallel, our reason over here should be the converse. Okay? So that's the only reason I keep doing that. Okay, so we're going to go ahead and try another one now. This one's a little bit more complicated because we're actually given a pair of parallel lines. We're told A and B are parallel, and we're told that 5 is congruent to 8. And then from here, our goal is to prove that C and D are parallel to each other. Okay, so just like every proof, let's go ahead and write it down. Okay, so I've got 1, A is parallel to B, and angle 5 is congruent to angle 8. And of course, our reason given. Now, whenever you have a proof that has more than one pair of lines that appear to be parallel, I suggest that you color over those two lines with a highlighter or something, or even your pencil, just so you're focusing your attention on those, and so that way you're not looking at C and D as being the parallel lines. So for me, like right now, I'm looking at these two red lines going, okay, well, I've got two types of angles, right? If I'm looking at this transversal, I know I have 6 and 5, which happen to be what types of angles? 6 and 5 are alternate interior angles. And again, we're starting with parallel lines. So we're actually using the theorem right now, right? If I actually flip back to the front, it says if you have parallel lines, then these certain types of angles are congruent. So I can actually state that 6 and 5 are congruent using the AIA theorem. Or if I decide to look at the other transversal here, 8 and 7 happen to be what type of angles? Do you see the C? 8 and 7 are consecutive angles, okay? And consecutive angles are supplementary. Now, for us, when we're doing proofs, we try at every single chance we have to not use consecutive angles. Because remember, consecutive angles are supplementary. They add to equal 180. And if we don't have to write the measure of 7 plus the measure of 8 equals 180 in a proof, it just makes it a lot easier. Okay, so when in doubt, if you have two of them, never do consecutive, always do corresponding, alternate interior, alternate exterior. So since we have the choice, we're going to use these alternate interior angles. Okay, so step 2, since A and B are parallel, I can write down that angle 5 is congruent to angle 6 using the alternate interior angle theorem. And again, if you reread it, it says if lines are parallel, which I do have lines A and B that are parallel, then the alternate interior angles are congruent. And that's what we just stated right here, right? We just had angle 5 and angle 6 are congruent. Okay, so now that we have that, look at our proof. Every single time we always look here to see, did we repeat anything? Oh, we sure did. What's repeated? Hopefully you guys are all saying 5. Angle 5 is repeated. So I can get rid of angle 5 and then I can put together angle 6 and angle 8. And right whenever I cross it off and combine them, that's called the, starts with the T, the transitive property. Okay, now one thing that's really going to help us once we've identified a new pair of angles that are congruent, we want to mark them off in our picture. So we just said 6 and 8 are congruent. So here's 6, here's 8. Okay, and 6 is formed using line C. 8 is formed using line D. And those are the two lines we're trying to prove are parallel. Aren't angle 6 and angle 8 using line A? So now if you just kind of retrain your brain to think about line C and D being your parallel lines and line A being your transversal, you can ask yourself, what kind of angles are 6 and 8? And if 6 and 8 are congruent, wouldn't line C and D be parallel? So if I look at my new drawing here, what kind of angles are 6 and 8? Aren't they corresponding angles? They're both below this transversal right here. They're both on the left side of these parallel lines. So now I can state that line C is parallel to line D using the corresponding angles converse theorem. Remember, we're trying to prove they're parallel? Every time you try to prove they're parallel, it is the converse. Whereas when it's theorem, you should have angles that are congruent. Okay, so it's the theorem when it's angles, it's converse when you're trying to prove that they're parallel. Okay, and that's it with this one. Okay, so now we have the perpendicular transversal theorem. It says in a plane, if a transversal, which our transversal here is line J. Let me change the color because I didn't realize I was on black here. Okay, so if we're looking at line J here, if it's perpendicular to one of two parallel lines, so since J is, let's say, J is perpendicular to H, which here's H. Okay, then it's perpendicular to the other line. Okay, so we already have that H and K are parallel to each other. This theorem is saying if J is perpendicular to H, and of course we have the fact that H is parallel to K. So if we have that, then we automatically know that K is going to be perpendicular to J. So it's basically saying that this angle is also a right angle, which totally makes sense. What type of angles are 2 and 6? These are parallel. What type of angle are 2 and 6? Aren't they corresponding angles? Aren't corresponding angles always congruent every single time you have parallel lines? So this is kind of a silly theorem in my opinion, just because we already know that if you have parallel lines, corresponding angles are the same. These just happen to be 90. Okay, so then that brings us to our last property here. It's called the transitive property of parallel lines. So it says if two lines are parallel to the same line, then they're parallel to each other. So let's say, for example, line A is parallel to line B. Okay, and let's say that line B is parallel to C. If we're using the transitive property, what is repeated amongst each of these? Isn't B repeated? So couldn't I just get rid of B? And then what would I be able to say? Wouldn't I say that A is parallel to C? So technically, A is parallel to B, which is parallel to C, since all three of these lines are going to be parallel to each other. So that's the transitive property of parallel lines is telling us. So we can apply that idea here. It's telling us that P is parallel to Q. We also know that Q is parallel to R. So if that's true, using the transitive property of parallel lines, P would be parallel to Q, which would be parallel to R. So that means that if this angle is 110, wouldn't this one also be 110? Wouldn't this angle right here also be 110? Because they're corresponding angles. Okay? And then from there, if all of those are 110, can't we find angle 8? Isn't it a linear pair with 110? So wouldn't the measure of angle 8 be 70 degrees using the linear pair? Oops, I wrote that wrong. The linear pair postulate. Right, if I know that this is 110, this one's got to be 70 for the two to be supplementary. That's a linear pair postulate. All right, you guys. So that leaves us with time to do our homework worksheet. Okay, so you have the rest of the hour to work on the homework worksheet, and then that should be done for Monday's class. All right, I hope you guys are doing great, and I will see you on Monday. Have a great weekend, you guys.